Hello everyone and welcome to STEM School. So today we'll be looking at algebraic fractions. So I'll explain exactly what they are and how to tackle the different types of questions you could be hit with in the exam. So before I get started, please do remember to hit the like button and consider subscribing to the channel. That will be fantastic. Alright, so let's get started. So algebraic fractions are simply just fractions that contain numbers, letters and even brackets. So we can have something like this. We can have 3x squared y cubed all over, something like 15xy squared, okay? That's an algebraic fraction. We can also have something with brackets in it. We can have 6x plus 2x minus 4 all over. We can have x plus 2 and we have x minus 4 all squared, okay? So it's just literally a fraction containing numbers, letters and brackets, okay? It's a little bit nastier. And the purpose of these types of questions is to be able to simplify the fractions as much as you can. So you need to find common factors on the top and bottom of the fraction and then cancel down when you're simplifying. This means that you need to factorize it if it's possible and, put fraction into single brackets or put them into double brackets, right? And you'll most likely have to use this rule of indices here, where you have to subtract a power. So we have a to the power of m divided by a to the power of n is equal to a to the power of m minus n. So you're essentially just subtracting the powers here. Okay, so there are various types of questions that you could be asked. You could be asked to, just simply simplify the algebraic fraction. You could be asked to add or subtract a fraction. And finally, you could be asked to multiply or divide the fractions. And I'll go over the various exam questions covering these so that you're best prepared for these types of questions. Alright, so before we have a go at the exam questions then, I've got some tips that you should always keep in mind when you're approaching these types of questions. So the first tip is that you always want to try and think, can I factorize the top and bottom? Can I take a common factor out? Can I put this in single brackets? Can I put this in double brackets, alright? And then in the next question specifically, right, you want to always keep in mind that you don't want to multiply out the denominator, right? You want to keep everything in bracket form if it's possible, because that means it's easier to cancel down later on when you're trying to simplify. Alright, so let's see what this question is saying. So first of all, it's saying, show that for x isn't equal to minus 1, that 8x squared minus 8 all over 4x plus 4 simplifies to the form ax plus b, where a and b are integers. Okay, so the first bit I want to address is this statement here. So show that for x is not equal to minus 1. So in all of these types of questions, they always include a statement like this. So I don't want you to get confused by this and throw you off. Basically what this is saying, right, if you were to put minus x is equal to minus 1 into that algebraic equation, the denominator, so will go to 0. So 4 times minus 1 plus 4 is equal to 0. So what you're doing is you're essentially dividing by 0, which is undefined. So this algebraic fraction doesn't exist for that for that value of x, okay? That's all that is saying. So you don't want to get confused by that. So let's have a go at approaching this question then. So let's write it out. We have 8x squared minus 8 all over 4x plus 4. Okay, so what you want to keep in mind is, can I take a common factor out? Can I factorize it? Okay, so if I look at this, I can factorize this for sure. So on the numerator, I can take a factor of 8 out. So 8, then it'll be x squared minus 1 on the numerator. Then let's say we can factorize the bottom, the denominator, so we can take a factor of 4 out. So we can take 4, then x plus 1, okay? Now, can I simplify this yet? Well, I can definitely simplify the numbers. So 8 divided by 4 will be 2, right? So this will cancel down and this will go to 2, right? So let's write that out. So it'll be 2 x squared minus 1 all over x plus 1. Okay, so that's how you sort out the numbers, right? But can I simplify this anymore? Well, see if I analyse this bit here, the bracket on the numerator, well, I can actually put that into double brackets, okay? I can actually expand that out. So what I can do is I can do 2, then this set up the brackets, okay? So x squared minus 1, if I want to put that into double brackets, right, I'll have to have 1 here and 1 here. So what we have, it will be x plus 1, x minus 1 for the numerator, okay? And then the denominator will just be the same, okay? So the reason why I did that, because now I can actually simplify down, right? Because we have the bracket x plus 1 on the numerator and we have the bracket x plus 1 on the denominator. So all we can do is just cancel them out, okay? Because they appear on both the top and bottom, okay? So what do we have left over? We have 2 and then just x minus 1, right? And that's the final answer. You always want to see, can I simplify this more and more, okay? And that's the final answer anyway, as the question explicitly says, it will be in the form ax plus b. So if you multiply this out, it will be 2x minus 2. Alright? Okay, so let's have a go at the second exam question then. So we're told to express 4 all over x minus 2 minus 3 all over x plus 5 as a single fraction in its simplest form. And we're told the statement that these algebraic fractions don't exist for the values of x is equal to 2 and x is equal to minus 5. Okay, so just to reiterate, okay, so see this statement, you don't want to get confused by this. What it's saying is if you put the values of x is equal to 2 and x is equal to minus 5 into these algebraic fractions, that means the denominator will equal 0, and when you're dividing by 0, the fraction's undefined, okay? So the algebraic fractions don't exist for those values of x, okay? So that's all it's saying. So here we've got the question where we just have to take away fractions. You know, the alternative is we could be asked to add fractions, right? So we've done that before. When you want to take away fractions, you want to make sure that the denominators are the exact same as each other. That allows us to do that. Okay, so let's have a go at this question then. So we have 4 all over x minus 2 minus 3 all over x plus 5. Okay, so like I said, we want to get the denominator the same, which means that we can actually take away them properly. So what we have to do is we do 4 all over x minus 2, and you divide and you multiply the top and bottom by the opposite denominator. So we want to multiply by x all over 5 all over x plus 5. So I want you to appreciate that we're essentially multiplying by 1. So we're not essentially, you know, changing it that much. We're just multiplying this by 1, okay? And then what we have to do to the other algebraic fraction, we have 3 all over x plus 5. And then you want to multiply the top and bottom by the other denominator. So x minus 2 and x minus 2, okay? So you're essentially multiplying by 1, right? So what does that give us? So what we can do, we have 4 multiplied by x plus 5. So again, try keep it in brackets when you're doing this first multiplying, okay? So if you look at the tip at the top of the page. So now this multiply the denominators. So x minus 2, x plus 5, okay? So don't multiply it out, just keep it in bracket form, okay? It makes it easier to simplify later on. Okay, let's do the second one. We have 3x minus 2 as the numerator, and then the denominator is x plus 5, x minus 2. Okay, so far so good, right? So what you want to do at this stage is just multiply out the numerator and just leave the denominators out. We have the exact same denominator, right? So that means what we can do is 4x plus 5, and then we have 3x minus 2, and that's all over x minus 2 and x plus 5, okay? So we can write it, we can combine it like this because the denominators are the same anyway, okay? So we can actually just take away the numerator now. So let's do that. So let's multiply out the brackets. So we have 4x plus 20, then we have, now you have to be careful here with the minus, so just to make it easier for you, you can just write brackets here like this. I do this all the time just to make sure I don't mess up with the minus. So you have minus, So let's multiply it inside this square bracket. We have 3x minus 6, okay, all over x minus 2, x plus 5, okay. So as I said, just keep the denominator in the bracket form. So let's keep going, okay. So we have 4x plus 20, then we have minus 3x, and then we have positive 6, right? So that's why I tend to put the brackets around it, just so I don't mess up with the minus here, right? So let's keep going. X minus 2, x plus 5, okay? Now at this point, just tidy up the numerator, and you want to see if you can cancel down if it's possible, right? So 4x minus 3x, we have x, then we have positive 20 plus 6, so we have x plus 26 in the numerator. Then the denominator is simply x minus 2 and x plus 5, okay? So that's the final answer, because if you actually look at it, you can simplify the top and bottom. There is no common factor appearing in the top and bottom to cancel down, okay? And finally, we have this question where we have to divide, okay? So we've been told to express n all over n squared minus 4 divided by 3 all over n minus 2 as a single fraction in its simplest form. And we're told the statement that these algebraic fractions only exist for values of n not equal to minus 2 and n not equal to 2. So again, you know, if you put these values of n into the denominator, they'll equal 0. And when you divide by 0, you get an undefined fraction, okay? So that's all that statement is saying. So let's have a go at this question, okay? So what you want to do is write it in this form. So n all over n squared minus 4. And you want to divide by 3 all over n minus 2, okay? So when you get this kind of format where you have a fraction over a fraction, you just want to think the flip, okay? Just keep that in your head, flip, okay? What do I mean by that? So what we're doing here is we're doing n all over n squared minus 4, and we can actually times it by the reverse, so we can put n minus 2 all over 3. So that's what I mean by flip, okay? So that's a useful thing to always remember. You just flip this bottom fraction and you multiply it instead of dividing. So that's easy to multiply it, because what you're doing is multiplying the numerator by the other numerator and the denominator by the other denominator. So let's do that. We have n times n minus 2 all over 3n squared minus 4. So like I said, try to keep things in bracket form, and we'll try see if we can cancel out later on, so we don't multiply out the brackets. So what can we do here? Can we cancel down any further? Well, we can actually look at the denominator. We have n squared minus 4. So we can actually write this into double bracket form. So let's have a go at doing that. So we can do 3, and we'll set it up so we have n, and then brackets there. Okay, so we have 4 here, so that means we can put 2 here, and we can put 2 here, and that means we'll have a plus and a minus there. Okay, so that's us put this expression into double bracket form. Okay, so the numerator is n minus 2. Okay, so if we have common factor appearing in the top and bottom, we have the n minus 2 bracket appearing in the top and bottom. So that means we can cancel them out. So that means if we keep going, so our final answer will just be n all over 3n plus 2. Okay, so that's our final answer. We've simplified it as much as we can here. Okay folks, so that's all the different types of exam questions you could be asked about algebraic fractions. So I hope this video has helped you understand it much easier. Again, please do like the video and consider subscribing to the channel, and I'll see you in my next video where we'll look at simultaneous equations.